For goal 3, we are going to try to identify the independent and dependent variables using the axes of a simple graph. So for this first part, we have where does the independent variable go on this graph? Well, independent, that's what we have control of. And anytime we have control of something, that's actually always going to go on the x-axis. So this is B, the x-axis, okay? Which means the dependent variable, all right, depends on the x that we choose. That's going to be A, the y-axis. For number 7, if we compare the length of a string of a pendulum to how fast it moved, the speed of the pendulum would be graphed on which letter? So we're looking at the speed. So the question is this independent or is this the dependent variable? Well, if we're looking at this, we only have the capability to be in control of one of these, and that is going to be the length of the string. Because what we're going to do is we're going to change the size of this string, and when we let the pendulum go from the same height, then how fast it moves is going to depend on the length that we picked. Okay, so if we're talking about the speed of the pendulum, how fast it moved, that's the dependent variable. So this is going to go, so this is dependent. So this is going to go on the y-axis, okay, because the speed depends on the length of the string. For number 8, if we want to determine the effect of changing the height of the ramp, and then we're going to see what that does to the speed of the cart, we would graph the height of the ramp. So the thing is, what are we controlling? Well, we are changing this. This is I am in control of this. So the height of the ramp is our independent variable. So that's going to be B, the y-axis, or the x-axis. For goal 4, we're going to determine which hypothesis or conclusion is consistent with the simple charts and graphs given. So we have a group of students carry out this investigation. They took a wire and they attached it to a battery. Then they measured the current, and then knowing the voltage and the current, they calculated the resistance, and then they repeated the steps. So what would be a good conclusion for this experiment? Okay, so the thing is, they have the longer the diameter, the higher resistance. So let's take a look at this table. It's like, all right, the longer the diameter. So I can see that happening. So this did happen, right? And then we want to look at the resistance. And I get 375, 37.5. And I'm like, nope. As this increased, this went down. So it's not A. The longer the diameter, which did happen, the lower the resistance, this did happen. So your answer here is going to be B. For number 10, which of the following graph summarizes? Okay, so I have current on the bottom. So the thing is, though, I was changing the diameter, but that's okay. So we have here current. Let's take a look at current. So current, when current increases, which is happening here, what does the resistance do? When current increases, resistance goes down. So this is increasing, increasing. Well, here, when current increases, the resistance increases, so it's not A. Here, current increases. What does the diameter do? Well, when the current is increasing, the diameter is also increasing, so it's not B. Resistance is going down, right? But if we flip-flop it, then we have to flip-flop these. Okay, so if I'm flip-flopping and saying this is doing the opposite of what's happening, if I'm increasing, so I'm going from the bottom up instead, then these two are going down. Well, here, as resistance increases, right, the current does decrease. So it's got to be C. So again, here, resistance as it increases, the diameter is also going to decrease, so that one does not work. And then for 11, Maria's hypothesis was that the water temperature would decrease if the water was deeper. So this is the water depth. So the depth is increasing. It is getting deeper. So this happened. And then she said that the water temperature would decrease. So as the water depth got deeper, did the temperature get deeper? Or did the temperature decrease? 18, 15, 12? Yes. So the temperature decreased as the water depth was greater. So was her hypothesis correct? Yes, it was.